motion problems. And motion is going to have to do with distance equals rate times time. Okay, and so when we're looking at these scenarios, what you will likely do is you'll have two things that are either traveling the same distance or traveling for the same amount of time. And then you're going to find the information that they're asking you from these problems. Okay, so I'm going to try the first one here, or I'm going to go through the first one and have you try the second one. So when we're looking at this first one, as far as the information provided, is that you have a plane that flies at a given rate, and you have a the plane that flies a given distance and a car that travels the same distance. And notice that the time is the same. So in this particular case, our t value is going to remain the same, but the d's and the r's will be different. Okay, and so we see that the car travels 80 miles per hour slower than the plane. So if we take this information and kind of express what we're looking at, we have two different scenarios. I'm going to call the plane number one, and I'm calling the car sort of scenario two here. So I have distance one is equal to rate one times time, and I have distance two is equal to rate two times time. Notice I established that the time is the same, so I'm going to label both of those just t, but I use subscripts for each of the other variables. Okay, so I know that my distance for the plane is 440. My rate for the plane is r, okay, and my time for the plane is t. Okay, or I'll call this r1. Okay, with regard to my car travels a distance of 120, so I can substitute that in for d2. And it says here that the rate is 80 miles per hour slower than the plane. So if my plane's rate is r, then this rate is going to be r minus 80. So again, here notice I'm going to take away my subscript because I'm just using r now, and I'm going to define the rate of my car in terms of the rate of the plane. Okay, and then the t value stays the same. So what I can do right here is I can solve each of these equations for t. So divide both sides to isolate my t. And now I have two expressions here and here that are both equal to the exact same thing, t. So I can set those expressions equal to each other and solve the resulting equation. So I'm going to go ahead and do that over here. So 440 over r is equal to 120 over r minus 80. And so here is the equation that I'm representing. And so now it's just a matter of solving this for r. And remember, the r is going to be the rate of that plane. So if I cross multiply, I wind up with 120r is equal to 440 times r minus 80. And I can multiply and get rid of my grouping symbols. 120r is equal to 440r minus 80 times 440 is 35200. And so now it's just a matter of combining my like terms. I'll move all my r's over to the left. Again, notice I get a negative number. That's fine. I wind up with negative 320r is equal to negative 35200. And when I isolate to solve for my r completely, I get my rate to be, the negatives cancel, and I wind up with a rate of 110. So I know that my plane has a traveling speed of 110 miles per hour. Okay, therefore, the car is going to be what we see from right here. The rate of my car is 110 minus 80. And so if I simplify that, I get the rate of my car to be 30 miles per hour. Okay, and so that would be my solution for that problem.